Okay, so today what we're going to do is we're going to talk about limits. And you haven't had these in any other class before. So there's a couple things when we start this, just like when we did the function analysis and we talked about the vocabulary, we have to get our vocabulary right so we can do this, okay? So here's the first thing, and I know these pictures are not super clear, okay? I know that. But like if you look right here, this is a guy playing soccer. And I think, isn't that, or football, whatever. But I think, isn't that, he's dribbling? Isn't that what you call that when you're, all right, so he's dribbling it. And then what did he do here? He kicked it. But then the TV started buffering. So the TV buffered. Right here. So the TV buffered. I hate it when that happens. But then what happened here?
No one blocked it. He's about to score.
Okay. But look, did you see him score?
I mean, no.
You didn't see him score, right? Because the stupid TV was buffering, and so we didn't see it. But do you know he did?
But somebody else could have kicked it.
All right.
There's no one there.
There's no one there. So do I know for sure he's the one that kicked it?
No. I mean, the dude could have blocked it.
The TV's buffering, right? So I don't know for sure what happened, but I know for sure what's the result. They scored the goal. All right, the same thing happens when you're watching TV and a football team is driving, right? And the TV goes out, and when it comes back on, the score is 7 higher. What happened while the TV was out? But how do you know? Because you didn't see it because the TV was out. You didn't see it, but the score went up, so you know it, right? So limits work the same way. Limits work exactly the same way. We may not know exactly what happens at that point, but we do know what happened. Just like we know that the score went up, so somebody scores, limits are going to work the same way. So, up to this point in time, everything you've done when you found slope, when you found the slope of a line, if I wanted to do slope, I'd do rise over run, correct? But what do I have to do rise over run? What, a line? I have to have 2 points, right? Well, we're smart, and we want to find it, but I don't want to use 2 points anymore. I want to use 1. And so instead of finding the average rate of change, which is what slope is, we're going to find the instantaneous rate of change, which is 1 point, and that's what a limit is. So, yes, you're going to have fun. You're not lost, and you're having fun. What? Oh, that's Miss Finnan's class, y'all, and they actually number theirs and put it on a specific page. Just slap that puppy in and niacin, and I don't care what page it's in, all right? All right. A limit is the idea of looking at what happens to a function as you approach a particular value of x. Okay, so listen and I'll tell you, okay? Okay, so just like everything we did with the intervals, we use the x's. Limits also use the x's. So we're going to find a y value as I get close to an x value. So there's a left and a right-handed limit, and it's as you approach a particular value of x from either right or left. And I know this isn't particularly clear right now, but we just have to have some vocabulary, okay? So, first of all, this is how we're going to write it. The limit of f of x as x approaches the values from the left. From the left. So I'm going to write the limit of f of x, and x is approaching the value of a. So underneath the limit, I'm going to write x approaches a from the left. And the left-hand side is the negative side. So on the graph, this is my negative side. Because that's where my negative x's start, right? So that's how you're going to remember it. It's going to be the left-hand side. The limit as x approaches the value of a from the right is written the limit as x goes to a from the positive. And that, okay, do you think I just put it up there for my health? Yes, you do. Okay, left-hand side is negative, right-hand side is positive. Yes, you are putting them. So looking at f of x when x equals negative 2. So on the graph, when x equals negative 2, right here. Do you see this? Here's my x value of negative 2. I want the limit of negative 2 from the negative side. So I'm going to negative 2. I'm going to put my little handy-dandy pencil on the left-hand side of the graph. And I'm going to go up the left-hand side, and this is my negative 2. So what number am I approaching in the y value? 1. Even though it's open, this is like the TV buffering. I don't care that I don't know what it is. I know that that number is approaching 1. So the limit here is 1. But now I want to do the limit of negative 2 from the positive side. So if I come over here to the positive side, if I approach negative 1 from the positive side, what's my y value this time? 3. Okay. So listen, what x value am I going to? And which side am I going to negative 2 from? The right. So if I take my little pencil and put it on here, and from the right-hand side, what's the y value at negative 2? 3. Okay? Now, what we had on our last test, if I look at this, what is the function value of negative 2? It's 3, right? Because that's when the open circle does make a difference, right? Okay, there's nothing opposite about it. The function value at negative 2 is 3. Okay? We already did that. We've done that. You've done it for years. All right, I'm looking for the y value at negative 2. The only one there is 3. The limit, it doesn't matter if it's open or closed because we got the TV buffering. All right, so using the same graph, this time I want to know the limit as x goes to 1 from the negative side. So I want my x value at 1, and which side am I coming from? So that's this side. So what's the y value when I come from this side? 2. So now I want the limit as x goes to 1 from the right side. So if I go from the right side, what's the value of y? 2. And we don't care that the TV is buffering. I know the y value is 2. These are x's, these are y's. Your answer is the y. Now this one, what is the function value of 1? Yeah, what's the function value of 1? It's an open circle. It doesn't exist. Well, wake up, because we're not done.
Why did you get the full curve? I don't get that. Like, you know how, like, for the second example, on the bottom, remember? Like, why did you get the full curve? Wouldn't it be like, you know what I'm talking about?
No.
Okay, the blue on the graph. Yeah, like, how did you start from, like,
It doesn't matter where you start. Just start from the right-hand side.
and I end up,
At x equals this. Okay. So, the next example. The next example. The limit of g of x, so this is labeled g of x, so this is my graph g of x. I want the limit as x goes to 0 from the negative side. So, x goes to 0 where? Where is my x 0? Right here, and I want from the negative side. So what y value do I approach at 0? Negative 1. Now I want to look at the limit as x goes to 0 from the positive side. So what is it? So what is the function value of 0? It's negative 1, right? So this time they all happen to match. So now I want x goes to 1 from the negative side. X goes to 1 from the negative side. So if x is going to 1 from the negative side, what's the y value? Negative 2. If I go x goes to 1 from the positive side, what's the y value? What is the function value this time? What is it? There's a dot there. 0. Okay? Are we having fun?
no.
Who said I don't get it? I'm punching you. Ask a question. But you're not the only one that doesn't get it.
Does it matter which class
So this time it's still the same thing, right? But it's not always going to be the same thing. Okay. Let's do this example. Okay. First of all, what x value am I going to? 4. So let's find 4 on the graph. Where is 4? It's the asymptote, right? Okay, so listen. Shh. This is my x value right here. So if I'm approaching the asymptote from the left-hand side, so put your little pencil on the graph from the left-hand side, what's happening to my y's? Down to what? Which infinity? Now, if I do the same thing from the positive side, where's my y values going this time? positive infinity. Do these match? They don't match. Okay, that's the next thing we're going to do, okay? So what we have is we have a right-handed limit, a left-handed limit, and a function value. That's what we have. So by considering both the left and right-handed limits of a function as you approach a particular value of x, you can determine whether or not the limit of that function at that point exists. And just like in this example, if the limit from the left and the limit from the right don't match, the limit does not exist. If the limit does match, then it's that number. So these match. So the limit as x goes to 0 is -1. The limit as x goes to 1 is -2 because they match. So you see this doesn't have a positive or a negative, so they match. But this one, the limit doesn't exist because they don't match. Okay? So that's why you have a left and a right. They have to match for the limit to exist. If they don't match, the limit does not exist. No. It says does not exist. Okay, so to find if what the limit as x goes to 1 is, I have to look at the limit as x goes to 1 from the negative side and the limit as x goes to 1 from the positive side. So the limit as x goes to 1 from the negative side. So first of all, here's x equals 1. From the negative side, what's the y value? 2. From the positive side, what's the y value? 2. Do they match? So the limit is 2. So we have to do both here too. The limit so the limit of -2, so I'm going to write here, the limit from the left-hand side, what's the y value? 1. The limit of -2 from the positive side is 3. Do these match? No? The y value, darling, the y value. If I go to -2, what's the y value? Always the y. This one too. If I go to -1 from the positive side, the y value is 3. Do they match? No, so it doesn't exist. Okay, so look, Okay, look. Here's my -1. What's the y value? I'm not being ugly, but I don't understand what you're confused on. The -1, what's the y value? 3. This is always the y value. What do you mean it's not from the positive side?
So negative side is coming left to right, positive right.
Yes.
So there's a negative right up and down.
Okay. All right, I want all of you to fill this in. Mm-hmm. Okay, fill them all. You did them? You're good. Yeah. When I'm done. I'm almost done. Not that one.
I get the positive. No, the negative. I don't get the positive.
Okay, so if I go from the negative side, what's the y value? -2. If I go to 1 from the positive side, and I know it looks like it's a -y, right? But the positive side is the positive x's down to the lower x's, all right? We're moving right to left. So it doesn't matter, you're starting down here. What's the y value? -2. Do they match? So the limit exists at -2. And what's the function value at 1? 0. Okay, so now the limit as x goes to -5. So here's my -5 right here, correct? So let's come back to that one. Let's start with this one. Well, let's skip that one too. Let's do this one. The limit as, we'll come back to those. The limit as x goes to 0 from the negative side. So the limit as x goes to 0 from the negative side goes to 5. Okay. The one right underneath of it, the limit as x goes to infinity. Now be careful. I want the y value. What's the y value as x goes to infinity? What's this going to?
But like, it doesn't say if it's positive or negative.
It goes to 0. It doesn't have to. So look. Okay, so if it doesn't tell you, you have to check both. So this way and this way both are at what value? 0. All right? Now, the limit as x goes to -5. So it doesn't have one there, so you have to check both. So if I check from the positive side, what's my y going to? If I check from the left side, what's my y going to? What's over here? Do you know what's there? So they can't match. So this does not exist. So listen to that again. I can get this from the positive side, but there's nothing over here. So I don't know what this side is, so they can't match. The limit as x goes to -infinity. So the limit as x goes to -infinity. So if I look from the positive side, oh wait, oh, -5 exists. I was doing this one. Sorry guys, that was me. I was thinking about how I was going to explain this one. So the -infinity one, right? This one goes to positive, but there's nothing on this side. So this one can't match, so they don't exist. I'm sorry. That was me. That was me. But the -5, right here, the limit from the positive side goes to what y value? The limit from the negative side goes to 1, so the limit is 1.
Can you re-explain this?
Yes. But it wasn't that confusing because the limit as x goes to -infinity. So the limit from the right-hand side is, what's the limit from the left-hand side? So they don't match, so it does not exist.
Okay.
Okay.